So we're looking at inputting values to these. The next one we're going to get here is negative 3 times 3 plus 7. So negative 9 plus 7, negative 2. Negative 3 times a negative 1 plus 7 is going to give us 3 plus 7 or 10. Negative 3 times 0.5 plus 7 is going to give you negative 1.5 plus 7 or 5.5. Negative 5, or gosh, negative 3 times 2.5 plus 7. What's that going to give me? 6. 7.5, right? 14.5. Doing the next value with these, all essentially what we're doing is we're taking a value and plugging it in. 4 minus 10 is going to give me negative 6. Doing it for 3. 3 squared minus 5 times 3 is going to give me 9 minus 15, which is what? Negative 6. Negative 2 squared minus 5 times a negative 2 is 4 plus 10 or 14. Negative 1 squared minus 5 times a negative 1. 1 plus 5 or 6. And then I believe this is going to give me 50, right? Just plug that in quick. Doing it for our last operator, 4 squared minus square root of 4. It's going to give me 16 minus 2 or 14. 9 squared minus square root of 9. 81 minus 3. 78. 1 squared minus square root of 1, which is just going to give me 0. 16 squared is 256. 256 minus 4 is 252, right? And 3 squared, let's just do it in our head. 3 squared is 9. 9 minus, oh, let's just do this. 9 minus the square root of 3. We'll leave it as that ratio. 8, maybe 7.34, maybe. We are taking notes today, so do me a favor, copy these down. For those that are still finishing up their tests, you guys still finish up your tests. Okay. When you are done with it, just return it to my desk. I'm hoping to have them in by either today or tomorrow for you guys. I just need some time to grade it, see how we did. So, bear with me. Objective, evaluating functions, finding domain and range. We might not get to this bottom part to it. We might take this in for tomorrow, looking at what it means to have domain and range graphically for us. So we probably let's just take that for tomorrow. We'll have an easy day today. Only 3 homework problems today. Only 3. So I'll reevaluate it so we're all on the same page. If I need to go slow, I don't mind going slow with this. Any questions so far? Homecoming this week, excited. Homecoming game on Friday, excited. It's starting to get colder, that's exciting. Already on week number 7. That's crazy. Feels like it's been by so fast. I don't know. Does it feel like to you guys it's been by fast? Or are you just like, oh my god, I just want to get out of here because I'm a senior? A little bit of both? Yeah. A little bit of both? I feel you. I feel you. I was always working or with my girlfriend when I was a senior. Or did football. That was another thing. Girls are expensive. Girlfriends are expensive. And I'm pretty sure boyfriends are too, so it goes both ways. What is a function? This is 2.1, so we're going to kind of move on. This is the next chapter of the textbook. Coming at you fast on these. Here we go. Going to copy this part down. So let's look at this here. Sorry, gotta get more context. What is a function? So we're going to look at function notation, domain and range, inputs and outputs, independent, dependent variables, evaluating functions, everything and anything between. A function is a relationship between two variables, in this case x and y, such that each value of the first variable is paired with exactly one value of the second. This is also referred to as, I'm pretty sure hopefully you guys remember this, 1-to-1, one input to one output. And we want to be able to reference these. Okay. So here we go. Let's look at this. So copy down this. We have a function generator here up on top. We input a function of x, or you have an input value of x that plugs in. We do our operations, multiply, divide, add, subtract, take the square root, logarithm, natural log, whatever to have you. And it gives us an output value of f of x, which is also referred to as our y. A lot of you guys have already seen these last year. We talked about them when we did functions freshman year. We talked about what they mean and how to actually apply them, but this is just refresher today. So we're just going to try to identify a lot of things that we're going to see here. We refer to this as f of x. It's not f times x, it's not anything special. But essentially what this f stands for is the name, the function name. The name of function. The x here, that's in this thing, is our value. In this case, the input value. So whatever you want it to be. And this is our generator, or let's give it just a function, or let's just say equation. And then we're just going to put, we plug doesn't matter what it has to be, we can plug in whatever we want it to be. This is also referred to as our output. Whatever we plug in and whatever it generates for us, we want to be able to simplify it out. That provides us a output value. Okay. You guys remember doing a lot of these? I think you guys did a lot of these, right? We're going to look at it in more depth. Can I move on? Okay. Copy down that same problem, and we're going to be practicing some of these. Some of these are very, very straightforward. Others are not so much. We're going to bring this C, so I'll bring C right here. So I need to copy that one down below, because it's hard to see. We're given a function name f of x is represented by the equation x squared plus 4. And we're going to use this to generate our output values by using specific values for that function. Our domain inputs are represented by what's in the parentheses. So our x value is going to be 3, negative 2, square root of 5, negative x, and just x. Okay. The output values are what happens when we plug them in. In our first example, all it's doing is it's taking our 3 up in front of here, and we're going to go ahead and plug whatever that value is into f. So we're going to plug whatever we're going to get into this. In this case, 3. Squared plus 4. And we're going to get 9 plus 4, which is also 13. Input was 3, our output was 13. Doing the same process down below. we're going to take this negative 2, which will be our input, plus 4. We're going to get 4 plus 4, or an output value of 8. Doesn't necessarily have to be a whole number. Can be also radicals, can be decimals, can give us fractions. Doesn't matter what it is. Our input value for this next case is going to be the square root of 5. So again, just plugging square root of 5 into our function generator. Square root of 5 plus 4. Squaring the square root just gives me what? 5. Simply enough. Output value, 5 plus 4 would just give us 9. In our next one, it might look very similar to what the original has given us, and that's exactly what it is. Whatever our value input is, in this case happens to be negative x, that's what we're going to plug in. So even if it's a variable, even if it's slightly changed, we can still do the same operation. We're going to get negative x squared. Oh, we kind of keep this the same. Plus 4. Negative x squared is just going to give me x squared, and then plus 4 at the end. Do I need to factor this? No. There's nothing for us to factor out. We don't have to solve anything to it. I'm not asking you to solve. Give me the factors of x squared plus 4. Okay. In our last example here, it's taking the function itself and multiplying it by 2. So we can still perform operators by this. In this case, f of x is being multiplied just by 2. So if we had to put this in context, I would have 2 on the outside of here. And whatever the f of x function is, in this case it happens to be x squared plus 4. And that's it. All we really want to do is just distribute. So we're going to get 2x squared plus 8. Is this easy or hard? Easy. Input and output values. That's all we're going to look at today. And that's the first one. Because I think I'm going to do a better job on explaining domain and range. Because domain and range is important, especially for next year when we're talking about limits and values. How many of you guys are expected to take calculus, whether it be prep or honors? You're like, no. Okay. Here we go. Copy down the next type of problem. Copy down this next one. I think it gives us another one here. It's taking our input value, so the name of the function happens to be f of x again. And this time it's using the operator 2x squared plus 3x minus 1. So we're going to be doing them to all these. Using input values for these will be 2. So 2 times 2 squared plus 3 times 2 minus 1. Now I'm okay. Do you need to show this step? No. You could probably just plug in and go, okay, 2 squared is 4, 4 times 2 is 8, write 8 down. Oh, 3 times 2 is 6 plus 6. Right? You can just do that. I'm okay with that. You do not need to show me all this work. I'm just showing those that need the extra help. So this is 2 times 4 plus 6 minus 1. 8 plus 6 minus 1. Or what? Was that 13? Sorry, even my addition and subtraction is pretty sketch sometimes. Let's be honest here. Next one's going to give me 2 squared. Yeah, the final equation, if we really wanted to, would be our f of, what is it? What do we plug in? 2? the input of f of 2 is equal to 13. If you wanted to really write it out that way, we will. We will eventually get there. But yeah, the input values for those are going to be expressed that way. But we're gonna keep on building up to it. 3 plus wrong blue. 3 times negative 1 minus 1. I'm gonna kind of skip, jump, and see this is gonna be 2 minus 3 minus 1. What is that? Negative 2. My input for my x is going to give me 2 times negative x squared plus 3 times negative x minus 1. I'm going to get 2x squared minus 3x minus 1. In this case, we can't change anything around here. I'm not asking you to simplify out or solve for a value of x. The input value is simply 2x squared minus 3x minus 1. We don't know what the x values happens to be for these. And then our final case that we're getting out here, I'm going to try to write this a little bit differently, but we're going to see the outside values being multiplied by 2. Our f of x function happens to be 2x squared plus 3x minus 1. And all we're going to really do is just take that 2 on the outside and multiply it in. So 4x squared plus 6x minus 2. Easy or hard? Easy. Here we go. Next part that we're going to look at is a little bit more advanced. So we're going to take this up a little notch because we're going to do all these 3 different types. You do have examples like this on your guys's. You have to do. Jesus. You have to do homework problems like this today. Okay. So bear with me. We're evaluating the function using different variables, and the last one is a combination of 2 functions of f dividing by h. So we're going to have to plug those values in, simplify as much as we can out, and then divide everything by h. I'm pretty sure we're going to be able to pull an h out of this. So we want to be able to simplify out. Cool beans? So using the same operation, actually let's do this. Let's cancel this. Let's do this part. That one back there is going to kind of make it funky. Let's just get rid of that. That kind of makes our life a little bit nicer. So we don't have to worry about doing this. Let's even do this. Just make it this. Let's make it a little bit more easier for us to write values down. Because it's going to get pretty big once we get to the final stage. Our inputs for f of x is described as 2x squared plus 3. We modified it. So this is our function generator that we're going to generate when we plug in our x values. In our first example here, we're going to plug in our a because a is represented by the input value. Let me rewrite this. This will give me 2 times a squared plus 3, which is going to just be 2a squared plus 3. So that's our first example here. Easy enough. A plus h is the next generator. So even though these are 2 variables, we can still write them out the same way. Okay, we're just going to use this as our input value. So this is going to give me 2 times a plus h squared plus 3. We got to FOIL this bad boy out. So when we do FOIL, we're going to get this, and I'm hoping you guys believe me. A squared plus 2ah plus h squared plus 3 there. We're going to simplify this all out by distributing out that 2 to 2a squared plus 4ah plus 2h squared. plus 3. So this is our next part right here. We can't really reduce any of that down. Move it down a little bit. Now, in order for us to plug in everything for this bottom one, I'm going to kind of move this up here. We're looking at f of a plus h minus f of a all over h. So we're going to go ahead and plug those values in, but luckily we've already solved those out. We don't have to resolve everything out. Our f of h happens to be our equation here on the bottom. So let's kind of write this out. Right? This is the f of h, and then we're going to subtract out the f of a. In this case, our f of a, ooh, I'm using a new tool. This is so much fun. Our f of a we've already solved out for, which is right here. Look at that. Boom. And we're going to divide it all out by h. So we just got to do a little simplification over here. When we write this whole thing out, this is probably one that you want to do. 2a squared plus 4ah plus 2h squared plus 3 is the first one. And then that negative has to be distributed minus 2a squared minus 3 all over h. Can any of these things cancel out? 2a squares are going to cancel out. What else? Our 3's. So essentially what we're left with is this here. So we're going to kind of simplify that out. One last step. And it should always divide out by an h. 4ah plus 2h squared all over h. Can we pull out a GCF? We can pull out an h. 4a plus 2h. Still dividing this by h. What happens to those two h's? Cancels, right? Leaving my last beautiful thing of 4a plus 2h. All that work just to find that out. Yes?
B, where it says 2a, is that a squared or a cube? Where it says a, I don't know what, plus 2ah plus h squared. Is that 3?
Squared. Easy or hard? Yes.
Where did the H come from on top of the 4A?
I pulled out the GCF. The GCF that is both shared on this term right here can be pulled out by h and h squared. So I pulled that out to the front. Does that make sense? Yeah.
Cross out the H's, but then you put another H up the top.
Oh, this is for the upper part to it.
Oh.
That's part of that part. Yeah. Sorry. Not a lot of room. Let's have you guys try this one out. Let's do this one. Try this one out. Let's go and try this one out. Inputting our first value into 3x squared plus 4. Did you get 3a squared plus 4? Easy enough. Next one that you have to input is very similar to the one we just did. This should have got us 3a squared plus 6ah plus 3h squared plus what? 4. We're going to plug these all into our bottom C equation, which is going to take the most to do. We have our first one up here, a plus h over here. I'm going to rewrite this just for you guys. Is that too small to see? Yes, it is. Come on, Mr. Aguilar. 3a squared plus 6ah plus 3h squared. And then we're going to subtract that from the quantity of f of a, which is going to be minus 3a squared minus 4 divided by what?
You forgot the minus.
Did I?
Plus 4.
In this case, because I have the distributive property of this negative here, it should be negative. Did I make a boo-boo? Oh no, I forgot the 4. Well, let me erase this. For the blue, should be plus 4 minus. So we're going to do, okay. I see what you guys meant. 3a squared minus 4. Is that better? We're going to divide this all out by h. Do any of those terms cancel out? Which ones? 3a squared, negative 4 and positive 4, leaving me my inside terms. I'm going to get 6ah plus 3h squared divided by h. I'm going to be able to pull out a h, GCF, 3h. And then all I can do is just cancel those out, right? Boom, boom. Gives me what? 6a plus what? 6a plus 3h. That's all she wrote. Good stuff? Super exciting stuff, right? OMG. Here we go. Here's your guys' homework. You guys have plenty of time to finish this up. About 10 minutes left. We're going to do domain and range tomorrow. So don't freak out. I'm going to do a better job teaching you this because I think it's important you guys get it. This is your homework. Let me clear this up for you guys. So this, don't copy it yet. Don't copy it yet. Because you're going to freak out if you do it. Okay, take a picture. You're fine. Make it look very clean. So just do those 3. These are also located in your book if you choose to do them.